The Earth drifts through the black silence of space, a pale sphere wrapped in oceans, clouds, and memory. Yet beneath its quiet face lies a history older than imagination, carved into stone, pressed into fossils, dissolved into dust. For 4.5 billion years, this planet has endured. Continents have formed and shattered, mountains have risen and crumbled, seas have drowned the land and receded into emptiness again. If all of Earth's time were bound into a single year, humanity's entire story would fall not across months nor weeks, but in the final seconds before midnight on December 31st. Civilizations, with their towers and machines, would flash and vanish in less than the blink of an eye. What, then, of the deep silence stretching across the pages before us? Could another civilization, vast and intelligent, have risen and fallen long before the first trace of our kind? If so, what scars would remain? And what clues would we ever hope to find? Time is not a careful archivist. It is a restless ocean, swallowing nearly everything it creates. Fossils are rare, relics rarer still. Whole continents are consumed by the churning mantle, erased without record. In such a vast expanse, what is the lifespan of a city, a species, a culture? Civilizations are sparks against eternity, brief flares of light that burn and vanish in the vast, unbroken night of geological time. And so the haunting question lingers, unanswered. Are we truly the first to awaken intelligence upon this ancient Earth, or merely the latest in a forgotten lineage? One link in a chain that stretches further back than memory dares reach. Every scientific revolution begins not with an answer, but with a question. Sometimes it is a question that seems small, almost trivial. Sometimes it is one so audacious that it borders on heresy. In 2018, two scientists, one gazing outward to the stars, the other inward to the Earth, dared to ask such a question. Adam Frank, an astrophysicist at the University of Rochester, spends his life thinking in cosmic timescales. He studies how civilizations rise and fall across the universe, how intelligent life might appear on other planets, and how such life might mark its presence. His gaze is outward, into the silence between stars. Gavin Schmidt, director of NASA's Goddard Institute for Space Studies, lives in a different realm of inquiry. His science is earthbound, rooted in climate models, ice cores, and atmospheric chemistry. He studies how our own civilization has transformed the planet, and how those changes are preserved in the geological record. One man looks to the heavens, the other to the ground beneath his feet. Together they asked a question that bridged both domains. It appeared in a paper published in the International Journal of Astrobiology. Its title was simple yet provocative: The Silurian Hypothesis. Would it be possible to detect an industrial civilization in the geological record? On the surface, the paper does not sound like science at all, but like science fiction. And in a way it is. The very name Silurian Hypothesis comes not from geology or astronomy, but from Doctor Who, the long-running British science fiction series. In the 1970s, the show introduced an ancient race of reptilian beings, the Silurians, who had built an advanced civilization on Earth long before humans evolved. Buried deep underground, they eventually awakened to confront humanity, the newcomers who claimed their world. It was never meant as literal truth. But Frank and Schmidt repurposed the name deliberately, a signal that they too were stepping into speculative territory. They were not claiming that reptilian architects once ruled the Earth, nor that a lost civilization was hidden in fossils and ruins. Instead, they were asking a subtler, more scientific question. If such a civilization had existed, would we be able to find it? It is a question both innocent and dangerous, for buried within it is a challenge to the boundaries of science itself. Geology, paleontology, climate science, these fields deal in evidence in measurable signals. But here was a question that asked not what is, but what might have been. Frank and Schmidt's paper was careful. They wrote explicitly, "We are not proposing that any such civilization existed. The Silurian hypothesis was not an assertion, but an experiment in thought." Yet the act of asking was itself transgressive. For centuries, the idea of ancient advanced civilizations had been relegated to myth, to pseudoscience, to the fringes of credibility. To even touch the subject risked ridicule. And yet science is not only about what is respectable, it is about what is possible. Their paper was not a hunt for evidence, but a test of detectability. If humanity were to vanish today, What signals would we leave behind in the rocks and sediments? How long would plastics endure? Would carbon isotopes betray our combustion of fossil fuels? Would nuclear residues survive as ghostly fingerprints of our industry? And if those signals exist, could similar ones be sought in older strata, pointing not to us but to some other civilization buried deep in time? The question startled because it blurred the line between the speculative and the empirical. It used science fiction as a doorway, but once across the threshold, it became science of the most rigorous kind. It asked not whether ancient civilizations were real, but whether if they were, science could ever know. In that subtle shift lay its power. For the Silurian hypothesis was not a claim about the past, it was a mirror held up to the present. It forced scientists to confront how fragile our own signal may be, how easily the vast machinery of human industry could dissolve into silence. It asked, if others had come before us, could they already have been erased? And if we ourselves vanish, will we too be forgotten? This is the birth of the question, unsettling, provocative, but grounded in the tools of science. A question that turns myth into hypothesis, imagination into method. And it is here, in this fragile balance between speculation and evidence, that the story begins. For science, in its deepest form, is not the defense of certainty, but the courage to ask forbidden questions, and the patience to seek their answers in stone, in air, in time itself. Time, as humans know it, is shallow. A century feels ancient, 1,000 years unfathomable, and the sweep of 10,000 years already strains the imagination. Civilization itself is younger than the oldest trees still standing, younger than the ice that still rests on the poles. Yet the Earth is 4.5 billion years old. Its history is not measured in dynasties, or even in species, but in continents born and destroyed, in oceans rising and vanishing, in mountains rising from seabeds only to erode back into dust. To grasp this, scientists sometimes compress Earth's lifetime into metaphors. Imagine the planet's history written as a 1,000-page book. For 999 pages, no human exists. Dinosaurs come and go by page 985. Mammals diversify by page 995. And only on the final line of the final page, in the faintest of margins, do humans appear. Every pyramid, every empire, every skyscraper belongs not to a chapter, not to a paragraph, but to a single stroke of ink, a dot at the end of the text. In this light, the human sense of time is revealed as blindness. Memory sees back only decades. History preserves only thousands of years. Archaeology reaches tens of thousands. Geology, however, speaks in millions, in hundreds of millions, in billions. It is a scale so vast that even the longest human epochs vanish to invisibility. And geology is not merely a record keeper. It is also a destroyer. The Earth does not archive neatly. It recycles. Wind erodes cities into dust. Rain washes stone into rivers. Volcanoes bury landscapes in fire, then erase even the burial in lava. Plate tectonics drag entire continents back into the mantle, erasing all trace of what stood upon them. Over such scales, permanence is an illusion. The fossil record illustrates this fragility. Of all the species that have ever lived, less than 1% left behind fossils. Most life disappears without a trace, dissolved in decay, crushed in sediment, recycled into other forms. Hay fish must die in precisely the right conditions, buried in silt before scavengers arrive, compressed but not destroyed, preserved for millions of years. How much rarer, then, would be the fossil of a skyscraper? A city? An entire civilization? Even human artifacts built to endure betray their mortality. Iron rusts. Concrete fractures. Glass shatters. Plastics degrade under sunlight. Within tens of thousands of years, most of what we build will crumble. Within millions, only chemical traces may remain, embedded in sediments as strange anomalies. Our grandest creations, towers of steel, webs of circuitry, engines of industry, are but fragile shells against the vast patience of the Earth. This is the scale problem at the heart of the Silurian hypothesis. Human eyes, trained on centuries, cannot easily see what vanishes in millions of years. What feels enduring to us, pyramids, walls, monuments, is in truth a flicker, erased almost as soon as it is written. To seek civilizations in deep time is to look not for ruins but for whispers. Not for statues or machines, but for scars in the chemistry of rocks, for abrupt silences in the fossil record, for patterns that suggest not nature, but intention. And here lies the philosophical pause. History, as humans imagine it, is a record, a chain of causes and effects preserved in stone and memory. But geology tells another story. History is not preserved. It is mostly erased. What remains are fragments, rare and scattered, floating in a sea of silence. A tooth in stone, a spike of carbon, a layer of ash. From these shards, entire worlds must be imagined, entire pasts reconstructed. If our own civilization were to vanish, what chance would there be that its story would survive intact? What hope that future beings millions of years hence would know we existed? Perhaps none. Perhaps they would see only an anomalous layer of isotopes, a thin horizon of plastics turned to stone, a sudden extinction in the fossil record. And perhaps in that same way, civilizations before us could already have come and gone, leaving behind only mysteries mistaken for natural events. The silence of deep time is not empty. It is filled with questions. And in that silence, human certainty, about being the first, about being unique, dissolves. For Earth has carried many worlds upon its surface. We know only the last few lines of the last page. What came before is a story half erased, written in whispers, guarded by stone. If civilization were to end tonight, what would remain? The lights of cities would fade within hours. Towers of steel would crumble within centuries. Satellites would tumble into the atmosphere, burning to ash against the sky. Forests would reclaim roads, seas would flood harbors, and the silence of the planet would return. But in the patience of geological time, there is no silence. Every moment leaves a trace, every age a fingerprint pressed into the crust of the earth. If our story were to end, it would not vanish completely. It would be translated into stone. Among the first markers would be plastics. Born scarcely a century ago, they are now woven into every corner of the biosphere. Microplastics drift in oceans, accumulate in soils and fall with the rain. Within sediments they form strange new layers, tiny unnatural polymers, unlike anything nature has created. Over time they fuse with minerals, becoming plastiglomerates, stone forged from sand, rock and melted plastic. To future geologists they will be technofossils, enduring signatures of an industrial species. Alongside plastics lies concrete. Vast in scale, it now outweighs all living trees on Earth. Bridges, highways, foundations, even if ground to rubble, they will persist as an unnatural horizon. A mineral stratum rich in lime and ash, bound by chemistry no volcano ever mimicked. Metals too will speak of us. Humanity has mined the crust with an intensity no natural process replicates. We have concentrated copper, aluminum and rare earth elements into deposits more refined than any ore vein. Even if our buildings decay, the chemical signature will remain. Unnatural concentrations scattered across the globe, distinct from geological baselines. And then there are the isotopes, the ghostly residues of fire. Between 1945 and 1963, nuclear weapons testing spread radioactive dust across every continent. Cesium-137, plutonium-239, and other isotopes settled into soils and ice. Their half-lives stretch across millennia. Some will persist for tens of thousands of years. For any geologist of the distant future, they will appear as unmistakable markers, a thin radioactive line running through the strata, a silent testimony of a civilization that split the atom and scarred its world with fallout. Taken together, these traces form what scientists call the Anthropocene marker, a proposed new epoch in the geological calendar. It is a horizon line, sharp and global, that future beings could detect in drill cores and rock cuts. Plastics, metals, ash, isotopes, and a sudden extinction pulse of countless species, all converging into a signal that is unambiguous. Here, an industrial civilization lived. Here they changed their planet. To grasp this, scientists often imagine a thought experiment. 10 million years from now, the Earth is silent of humans. Ice sheets have come and gone. Mountains have risen and eroded. Continents have drifted. Somewhere on this changed planet, alien geologists, or perhaps a new intelligence evolved from Earth's survivors, lower a drill into ancient sediments. What would they find? At a certain depth, they would encounter a strange horizon, layers older than it looked natural. Carbon cycles driven by volcanoes, extinction pulses explained by impacts or climate shifts. But here suddenly the chemistry shifts. Carbon isotopes spike sharply, consistent with the rapid combustion of ancient hydrocarbons. Plastics appear in silt, now fossilized as synthetic minerals. Heavy metals cluster in unusual concentrations. A radioactive pulse marks the age of nuclear fire. Fossil assemblages show a sudden die-off of countless species, amphibians, birds, mammals, while a single species dominates in abundance, spread across every continent. To such geologists, the conclusion would be inescapable. An industrial civilization once lived here. It burned fuel, altered climate, manufactured new minerals, and spread across the globe. Its signal is faint compared to mountains and oceans, but it is distinct, a fingerprint etched into the rock, and this is the key insight of the Silurian hypothesis. If we can see our own fingerprint so clearly, then the same logic can be turned backward. If another civilization had risen millions of years ago, industrial in scope, it would leave similar traces. Its plastics may not be our plastics, but some synthetic analog. Its isotopes may differ, but industry leaves chemical scars. Its cities would crumble, but its sediments would remember. The silence of geology does not prove there were none. It only means that if they existed, their signals must either be erased or hidden, or so faint that we have yet to see them. The search then is not for ruins or artifacts, but for fingerprints, the subtle, enduring marks that industry leaves upon the earth. Here, imagination bends toward humility. For what we think eternal may in truth be fleeting. Our monuments may fade, our machines corrode, our knowledge vanish, but in the rocks, the earth will remember us by a thin horizon of plastic, ash, and isotopes. And if others once lived before us, it may be in similar whispers, hidden deep in stone, that their story still lingers. In science, some questions do more than invite answers. They unsettle the very foundation of human identity. The Silurian hypothesis is one such question. It does not claim to prove a lost civilization. It does not conjure Atlantis, Lemuria, or mythic ages of forgotten empires. Instead, it whispers something more disturbing, that geology in its vast erasures may be incapable of telling us with certainty whether we are the first civilization on Earth, or merely the latest. For generations, humanity has clung to a comforting belief that it is unique, that consciousness, language, technology, and cities are the inevitable crown of evolution, and that history has been leading inexorably toward us. Our pyramids, our satellites, our physics and art all seem to declare a singular destiny. We are the pinnacle, the first to awaken intelligence upon this world. But the Silurian hypothesis dismantles that comfort. It suggests that this pride may be fragile, that our place in deep time is not as secure as it seems. For in the Earth's 4.5 billion-year chronicle, humans arrive only in the last seconds of the last page. Before us lie hundreds of millions of unrecorded years, vast epochs in which oceans rose and fell, continents drifted, species flourished and vanished. In that immensity, what assurance do we truly have that intelligence did not bloom before, then perish, leaving only whispers in stone? The shock lies not in the claim, but in the method. Unlike pseudoscience, which trades in speculation and myth, this question is anchored in geology, chemistry, and testable signals. Adam Frank and Gavin Schmidt were not searching for Atlantis. They were not resurrecting old legends. Instead, they asked, if a civilization had existed millions of years ago, what traces would survive in the geological record? It is a profoundly scientific reframing. The test is not whether a myth holds truth, but whether science itself is capable of detection. If the answer is no, if industrial civilizations could vanish with almost no trace, then our certainty collapses. We cannot prove that we are first. We can only accept that the silence of geology may not be final. This distinction is vital, for the boundary between speculation and pseudoscience has always been fragile. History remembers countless tales of hidden empires beneath the sea, of ancient wisdom lost in flood or fire. Yet those myths, seductive as they are, crumble against the weight of evidence. The Silurian hypothesis, by contrast, does not indulge them. It strips the question bare, reducing it to chemistry and stone. No stories, no gods, no allegories, only isotopes, minerals, and fossils. It asks not what people once believed, but what Earth itself records. And it is here that the true paradigm shift unfolds. For science, long a fortress of certainty must admit a new humility. If the signals of civilization can be erased within a few million years, then deep time is not transparent to us. It is opaque, fractured, incomplete. It contains silences that no microscope, no mass spectrometer, no satellite can fully penetrate. This realization wounds human pride. It reframes us not as the sole dawn of intelligence, but perhaps only one among several. Perhaps civilizations are not singular events, but cycles, brief flares that rise, burn, and vanish against the endless dark. In this view, humanity's skyscrapers and satellites are not eternal monuments, but fragile echoes of patterns that may have come before. The shock, then, is existential. If we are not the first, what does it mean to be human? If the story of Earth has held others before us, what does that say about our future? Do civilizations always end? Not in fire, but in forgetfulness. Does intelligence itself contain the seeds of its own erasure? The cinematic weight of this hypothesis lies in its confrontation with time. In a universe where galaxies drift and stars collapse, humans long believed themselves to stand apart, rare, unique, perhaps even chosen. The Silurian Hypothesis pulls that belief away, replacing it with something colder, yet perhaps more profound, that the Earth may have forgotten other dreams of intelligence, just as it will one day forget ours. And so the scientific community stands divided. Some dismiss the thought as little more than philosophy, unnecessary speculation. Others see it as a profound recalibration of humility, a recognition that our ignorance of deep time is greater than our knowledge. In either case, the discomfort remains, for in imagining alien geologists sifting through our ruins, we are forced to confront ourselves. We are asked to see our civilization as a layer in stone, a thin stratum of plastic and isotopes, destined to vanish beneath oceans and continents. In that reflection lies the deepest shock of all, not that others may have come before us, but that we ourselves are already becoming geological memory. The Silurian Hypothesis is not a claim. It is a mirror. It holds up to humanity the unsettling possibility that we are not a beginning, but a continuation, not a first dawn, but perhaps only the latest. And in its quiet, testable logic, it delivers a blow more devastating than myth. The suggestion that we may never truly know. That is the weight of the forbidden question. That is the tremor it sends through the pride of human science. Their civilization confronted not with its triumph, but with the haunting possibility of being one more spark, swallowed, as all sparks are, by the vast ocean of time. The Earth remembers in layers. Every snowfall in the polar deserts, every wave that lays down a grain of sand, every eruption that spreads its ash across the horizon, each is pressed into the record of time. Though mountains rise and oceans shift, though much is erased, some signals remain. They are captured not in books or monuments, but in the chemistry of rocks, in the frozen air of ancient ice, and in the sediments at the bottom of the sea. It is here, in these geological archives, that scientists search for the fingerprints of civilizations. The tools of detection are as delicate as they are powerful. Ice cores drilled deep into the glaciers of Greenland and Antarctica contain trapped bubbles of ancient atmosphere. Each layer marks a season, a year, a century, frozen memories of the planet's breath. In these bubbles, researchers measure the rise and fall of carbon dioxide, methane, and other gases across hundreds of thousands of years. They reveal ice ages waxing and waning, warm periods blooming and fading, each pulse of climate recorded with precision, finer than the strokes of history itself. Then there are sedimentary layers, where rivers and oceans slowly gather the dust of continents, layering grains of sand, pollen, volcanic ash, and the remains of microscopic life. Buried within are chemical residues, traces of metals, isotopes, or pollutants that, if they exist, could testify to industry. Beneath the oceans, deep-sea cores preserve another archive. Slowly sinking particles, shells of plankton, fragments of dust, accumulate at a pace almost imperceptible, yet over millions of years they form strata, each centimeter representing thousands of seasons. Within them lie signals of past climates, past extinctions, past disruptions of the carbon cycle. Among these records, scientists have found anomalies, strange moments in time when the Earth convulsed, when the climate shifted violently, when carbon flooded the atmosphere with a rapidity that echoes today. The most dramatic of these comes from 56 million years ago. Known as the Paleocene-Eocene thermal maximum, or PETM, it was a moment when the Earth suddenly and catastrophically warmed. Global temperatures rose by 5 to 8 degrees Celsius in less than 20,000 years. A geological instant. The oceans acidified. Rainforests spread into the polar regions. Insects, mammals, and plants migrated across continents in desperate search of equilibrium. In the rocks, this event appears as a thin band of clay enriched with carbon isotopes, a chemical scar etched across the planet. It is, in many ways, the closest analogue to what humanity is now inflicting upon the Earth. Our burning of fossil fuels leaves behind not only gases in the atmosphere, but isotopic fingerprints, a depletion of carbon-13 relative to carbon-12. The PETM carries the same signal, a sudden massive release of light carbon into the air and oceans, but its cause remains uncertain. Some scientists point to volcanic activity, immense eruptions that may have destabilized methane frozen in the seafloor. Others suggest that the warming released carbon stored in permafrost or peatlands, a runaway feedback loop of greenhouse gases. Still others argue for asteroid impacts or complex interactions of tectonics and climate. And yet, the puzzle endures. The PETM unfolded with a speed and violence rarely matched in the geological record. It is not proof of anything artificial. It almost certainly has natural explanations. But it shows how difficult it is to distinguish between natural cataclysm and the hypothetical traces of industry. This is the uncomfortable tension. If an industrial civilization had existed in that epoch, its signals might not appear as ruins or artifacts, but as anomalies, sudden carbon spikes, disrupted ecosystems, strange chemical residues. To a geologist 56 million years later, such as those who live today, it would look identical to natural catastrophe. The fingerprints of industry and the fingerprints of volcanoes blur into the same chemistry. Other events echo this mystery. The Great Oxidation Event, over 2 billion years ago when oxygen suddenly flooded the atmosphere, killing much of the anaerobic life that had flourished until then. The Permian-Triassic extinction, 250 million years ago, when 90% of species vanished in what is often called the Great Dying. Each of these leaves signals in stone abrupt changes, sudden disappearances, unexplained shifts in isotopes. Each has natural explanations, and yet each reminds us that history, when seen through geology, is a tapestry woven of silences and anomalies. The PETM remains the most haunting parallel. For as humans drill into the cores of rock and ice, they see in its isotopic lines a reflection of their own trajectory. The current spike in carbon dioxide is faster still, unfolding in centuries rather than millennia. If our civilization were to vanish, its mark would look eerily like that thin band of clay from 56 million years ago. A chemical horizon speaking only of disruption, not of who or what caused it. The question, then, is unsettling. If another industrial civilization had risen and fallen before us, would we recognize it? Or would its story be buried in anomalies mistaken for volcanic eruptions or methane release, forever catalogued as natural events? This is not a claim of hidden empires or lost histories. It is a recognition of humility. The Earth's record is not perfect. It is fractured, eroded, overwritten. What survives are fragments, and fragments can deceive. Perhaps no one came before us. Perhaps humanity truly is the first to raise fire to the sky, to split the atom, to send machines beyond the planets. But in the quiet strata of stone and ice, there remain scars that mirror our own. And in those scars lies a question that refuses to fade. How much of Earth's past has been forgotten? How much will be forgotten of us? The search continues, not for monuments or ruins, but for patterns, for the chemical ghosts of civilizations that may never have existed, or may have been erased so completely that they are now indistinguishable from the planet's own convulsions. In the rocks and ice, time is both preserved and destroyed. Every anomaly, every unexplained spike, every layer of clay holds a mirror to the present. It reminds us that our story, too, will one day be compressed into stone, perhaps as nothing more than a thin, enigmatic line, awaiting interpretation by beings yet to come. And so the evidence lies not in myths but in chemistry, not in forgotten texts but in isotopes. The Earth speaks, but only in fragments and never in certainties. What remains is silence, interrupted only by anomalies that ask the forbidden question. The story of life on Earth is not one of smooth continuity. It is a story written in cataclysms. 5 times in the past half-billion years, the planet has been struck by upheavals so immense that they tore apart the fabric of existence itself. Entire lineages built over hundreds of millions of years were extinguished in geological instants. The oceans emptied, the forests burned, the skies darkened, and when the silence cleared, life began again, reshaped into new forms. These are the mass extinctions, the great punctuation marks of Earth's history. The most violent of them came 252 million years ago, during the Permian-Triassic extinction, known as the Great Dying. More than 90% of species perished. The seas turned toxic, anoxic, stripped of oxygen. The land baked under intense volcanic eruptions from the Siberian traps, spewing carbon dioxide and methane into the atmosphere. Complex ecosystems that had flourished for hundreds of millions of years collapsed in less than 100,000. Life itself teetered on the edge of annihilation. Later came the more famous catastrophe, the end of the Cretaceous period, 66 million years ago. A 10-kilometer-wide asteroid struck what is now the Yucatan Peninsula. The impact unleashed energy greater than 1 billion atomic bombs. Forests ignited across continents. Dust and sulfur choked the skies, plunging the planet into years of darkness. Dinosaurs, the rulers of the Earth for more than 100 million years, vanished almost overnight. In their absence, mammals, small, furtive, nocturnal, began their slow ascent, eventually leading to humans. There were others. The Ordovician Silurian extinction, 440 million years ago, when glaciers rose and seas receded, stripping life from the oceans. The Devonian extinction, 370 million years ago, when ancient reefs collapsed and fish species perished in waves. The Triassic-Jurassic extinction, 200 million years ago, clearing ecological space for the rise of the dinosaurs themselves. Each of these events carried the same dual nature, devastation and renewal. In the ashes of extinction, new branches of life emerged. With each collapse, the biosphere reset, opening niches for evolution to explore. Destruction, then innovation. Death, then possibility. This cycle poses a haunting speculation. In the long windows between these cataclysms, the stretches of stability that lasted tens of millions of years, could intelligence have risen before? Could an industrial civilization have bloomed, not in the fragile few thousand years that humans have occupied, but in epochs longer than all of recorded history, multiplied 1,000-fold? The silence of geology makes it impossible to dismiss entirely. Imagine the Devonian period, when forests first spread across the continents, covering the land with green for the first time. For 60 million years, the planet thrived in ecological balance. Or the Jurassic, when dinosaurs roamed beneath vast canopies and seas teemed with reptiles and ammonites. These were not brief moments. They were expanses of time so long that human imagination cannot hold them. Across such windows, intelligence could rise and fall many times over, its traces swept away in the churn of tectonics and erosion. Civilizations, if they emerged, would have been like constellations, bright patterns flaring briefly against the darkness of deep time, then vanishing into silence. The stars remain, but the pattern is forgotten. So too might Earth have carried brief constellations of mind, cultures that rose, flourished, and then disappeared, their memory extinguished not only in history, but in stone. Even in our own epoch, the Anthropocene, the shadow of extinction looms. Humans stand at the threshold of what some scientists call the sixth mass extinction, driven not by asteroids or volcanoes, but by industry, deforestation, and climate change. Species vanish at rates thousands of times faster than background extinction. Coral reefs bleach and crumble. Forests burn with increasing frequency. The balance is shifting. In this mirror, the past becomes uncanny. The Earth has endured collapse before. It has endured warming and cooling, impacts and firestorms. If humanity's actions push the biosphere into crisis, our mark will not be unique. It will be one more scar, One more sudden break in the continuity of life, and if we vanish, it will not be the first time intelligence has been erased, only the first time we know of. This is the deepening mystery. Extinction both erases and creates. It clears the board of life, but in so doing makes space for novelty. Intelligence, if it has emerged before, may always be fragile, a brief bloom between catastrophes. The cosmos may favor its rise, but Earth's cycles ensure its impermanence. The geological record shows us only fragments. It shows us scars of collapse and bursts of renewal, but not the whispers of culture or thought. It is blind to language, to tools, to art. It records only chemistry, only the abrupt silences of ecosystems. And in those silences, there is room enough for speculation. Perhaps humans are the first and only. Perhaps the story of life has been one long preparation for this singular moment. Or perhaps humanity is but another dawn, one among many that flared and faded, each erased by the same indifference of time. For Earth is patient. Civilizations may rise, but the planet endures. Continents drift, seas shift, mountains crumble, but life returns. Renewal follows extinction, as surely as dawn follows night. Whether humans are the first or merely the latest, the rhythm is older than memory. Constellations of mind flickering and fading, while the Earth spins on, indifferent and eternal. In 2018, two scientists, astrophysicist Adam Frank and climate scientist Gavin Schmidt, posed a question so audacious it shook the quiet corridors of geology and astronomy alike. If an industrial civilization had existed long before humanity, how would the Earth remember it? Their thought experiment became known as the Silurian Hypothesis, a name borrowed from science fiction. It was not meant as a claim that such a civilization did exist, but as a scientific exercise in humility. To ask what evidence, if any, would remain of ourselves millions of years from now. And more disturbingly, whether such traces could already be hidden in the rocks beneath our feet. The first clue lies in chemistry. Industrial societies do not merely reshape landscapes, they rewire the planet's very atmosphere. Since the dawn of fossil fuel combustion, carbon dioxide levels have surged to concentrations not seen in 3 million years. But this spike carries a fingerprint. The burning of ancient carbon deposits alters the ratio of stable isotopes, carbon-12 and carbon-13, in a way natural processes rarely mimic. In theory, such a shift could be preserved in sediments, an isotopic scar distinct from volcanic eruptions or methane seeps. If an ancient civilization once burned its equivalent of coal and oil, its legacy might whisper still, locked in stone as an anomaly in the carbon record. Yet the Earth is a master of disguise. Volcanoes, too, flood the skies with carbon. The Siberian traps, whose eruptions helped trigger the Great Dying, released enough greenhouse gases to destabilize the climate for hundreds of thousands of years. Methane clathrates frozen beneath the seafloor can rupture in sudden bursts, flooding the atmosphere with carbon lighter in isotopic weight. These processes leave signals that echo eerily close to the mark of industry, distinguishing the hand of civilization from the chaos of geology becomes a puzzle with no easy solution. Beyond carbon, there are subtler signatures. Industrial chemistry produces compounds that life never evolved to make. Synthetic pesticides, long-lived plastics, fluorocarbons, molecules alien to biology. Some can persist for tens of thousands, even millions of years. In theory, if an ancient civilization had mastered chemistry, its artifacts might be found not in temples or tools, but in the molecular debris of soil and clay. A chemical shadow of progress, detectable only through instruments that humans themselves have only just invented. But here too the Earth resists. Plastics degrade under sunlight and pressure, ground down by oceans into microscopic fragments. Over millions of years, even these may be buried, melted, or recycled through tectonic processes. Fluorocarbons, though, stable, dispersed to levels that blend into geologic noise. Time is a ruthless editor. Agriculture, too, leaves its marks. Today's industrial farming alters nitrogen cycles on a planetary scale, creating isotopic shifts in soils and sediments. If another civilization had cultivated vast fields or engineered landscapes, Its impact might linger in the ratios of nitrogen-15 to nitrogen-14, subtle clues buried in riverbeds and ancient floodplains. Even the domestication of plants or the mass production of food could echo in pollen records, fossilized spores, or genetic bottlenecks of species. Yet once again, the planet blurs the lines. Natural processes, wildfires, floods, even the proliferation of algae, can mimic these same effects. The signature of intelligence may be indistinguishable from the signature of chance. This is the central puzzle: how to tell the difference between an ancient Anthropocene and a natural catastrophe. To the geologist peering back across 50 or 100 million years, the two may appear as twins. A sudden warming, a spike in carbon dioxide, extinctions rippling through ecosystems. Was it the ignition of fuel by hands and machines, or the eruption of magma through fractured crust? Was it the rise of cities or the fall of an asteroid? In the Paleocene-Eocene thermal maximum, 56 million years ago, global temperatures spiked 5 to 8 degrees in less than 20,000 years. The oceans turned acidic. Polar regions warmed to subtropical climates. It is one of the most mysterious events in Earth's history, and its profile, when charted in stone, looks hauntingly familiar to the crisis unfolding today. Most scientists attribute it to massive carbon releases from volcanism or methane hydrates. But the question remains, if a civilization had existed then, would its footprint look any different from what the rocks already record? The unsettling answer is that it may be nearly impossible to know. The deeper one digs, the more the signals blur. Geology is not a perfect memory. It is a palimpsest, a manuscript rewritten endlessly by time. Mountains rise, erode, and vanish. Oceans open and close. The crust itself is recycled into the mantle, carrying ancient surfaces into fire. Even the best preserved records are fragments, like scattered pages from a lost library. If another civilization did rise in some forgotten epoch, its ruins may not lie waiting to be discovered in deserts or seabeds. They may already have been erased, dissolved into chemistry, indistinguishable from natural disasters that Earth has endured countless times before. Its story may be lost not because it left no trace, but because the traces it did leave are drowned in the noise of the planet's own restless cycles. And so, the Silurian Hypothesis becomes less a search for evidence than a meditation on impermanence. Humanity, with all its machines, satellites, and cities, may itself be destined to vanish into ambiguity. Millions of years from now, if another intelligence studies the strata, it may puzzle over the same question. Was there once a civilization here, or was it only the Earth shifting restlessly, as it always has? The thought bends the imagination toward humility. Civilization, for all its triumphs, may be but a thin line on the canvas of deep time, a flicker that vanishes as soon as it is drawn. The rocks do not remember the voices that spoke, the hands that built, or the minds that dreamed. They remember only the chemistry of disruption, the scars of extinction, the shadows of fire and flood. Perhaps that is why this question lingers, not as a matter of proof, but as a reminder. To search for predecessors in the silence of stone is to glimpse the fragility of our own chapter. Whether or not others came before, the Earth has a way of erasing all who rise. Civilization, however vast, is mortal. In the end, it may leave behind nothing more than an echo, a subtle anomaly, hidden in the strata, waiting to be mistaken for nature's own hand. The Earth is not only a world of oceans and mountains, it is also an archive. Layer upon layer, century upon century, its surface has kept records, not in ink but in stone and ice, in dust that falls through seas and freezes into glaciers. For those who know how to read it, the planet becomes a library of deep time, each page etched in minerals and molecules. Geologists call their craft a kind of forensic science. Where detectives study crime scenes, geologists study the scars of vanished ages. Yet unlike human crime, the mysteries of deep time stretch not across years but across millions. The evidence is fragile, fragmented, and often erased. To search for civilizations that might never have been, science must wield its most delicate instruments. Among these tools, mass spectrometry stands as one of the most precise. It can weigh the invisible, atoms and isotopes that betray subtle imbalances. Certain isotope ratios, like carbon-12 against carbon-13, can reveal whether the carbon came from volcanic eruptions, methane hydrates, or the burning of fossil fuels. If an ancient industrial civilization once transformed its world, the fingerprints might lie hidden in these chemical ratios, pressed into rocks older than any memory. Then there are sediment cores, long, slender cylinders of mud and sand drawn from the ocean floor. Each millimeter represents years, sometimes centuries of accumulation. Within their layers are pollen, ash, microplastics in our own age, and chemical traces of events long forgotten. High-resolution imaging allows scientists to scan these cores grain by grain, teasing out signals that the naked eye would never see. The ice, too, speaks. In the frozen vaults of Antarctica and Greenland, bubbles of air remain trapped for hundreds of thousands of years. They carry whispers of past atmospheres, spikes of carbon dioxide, sudden shifts in methane, traces of industrial gases. Ice cores offer the closest thing Earth has to a time machine, holding in suspension the breath of vanished climates. Yet the search does not end with Earth alone. To refine their methods, scientists turn outward toward other planets. On Mars, rovers dig shallow trenches, testing instruments that may one day identify traces of ancient habitability. On Venus, where a runaway greenhouse has transformed the planet into a furnace, researchers imagine what markers of past change might still persist beneath its thick clouds. By looking outward, humanity learns how to better look inward. This practice has been given a name: exo-civilization forensics, a discipline born from the search for extraterrestrial intelligence. The same signatures we might hope to detect in alien worlds, chemical disequilibria, isotopic oddities, or artificial compounds, are the very markers that might reveal a forgotten civilization on Earth itself. And so the paradox emerges. In teaching ourselves to recognize the ghosts of others, we may discover the ghosts of ourselves. The attempt to read distant planets forces a deeper question. In the rush of geology, in the silence of stone, has Earth already carried the memory of a civilization before us? The tools are sharp, the methods refined, yet the answer remains elusive. Evidence, if it exists, lies buried not just in rocks, but in riddles of interpretation. A spike in carbon, a shift in oxygen, a layer of ash. Are these the breath of volcanoes or the smoldering trace of engines that no longer exist? 18. Science listens, patient and unyielding. With each core drilled, each isotope weighed, each planetary probe sent across the void, the question deepens. Perhaps we are alone in history. Perhaps we are not. The rocks, the ice, and the planets themselves remain the only witnesses. The question that began as speculation has now turned inward. Humanity itself has become the test case. For the first time in the history of Earth, a species is conscious of its own geological imprint, aware that its existence is being etched, not just in history, but in the very crust of the planet. Scientists have given this new epoch a name: the Anthropocene, a term that means simply the age of humans. It is not a metaphor, but a proposal debated fiercely in geology and climate science. Has our influence become so profound that it marks the boundary between epochs, like the end of the Ice Age or the fall of the dinosaurs? The answer increasingly appears to be yes. Since the mid-20th century, the Earth's systems have entered what researchers call the Great Acceleration. In only a few decades, the atmosphere has filled with unprecedented levels of carbon dioxide, rising faster than any known natural event in the last 66 million years. Plastics, once exotic inventions, now drift through every ocean, fragmenting into microplastics that sink into sediments, forming a permanent layer of artificial polymers. Concrete, steel, and glass, produced at scales measured in trillions of tons, will not simply vanish, they will fossilize, becoming a new category of stone: technofossils. Even more indelible are the shadows of radiation. Between 1945 and 1963, over 500 nuclear detonations scattered radioactive isotopes across the globe. Plutonium-244, cesium-137, and others now lie within soils, lakes, and deep-sea clays. Some will remain detectable for millions of years. A future geologist, probing the strata of the 20th century, would find in these isotopes an unmistakable line, sharper and clearer than almost any boundary in the geologic record. Above the skies, the Anthropocene extends still further. The orbit of Earth is now haloed with thousands of discarded satellites and fragments of space debris. Though many will decay, Some may remain lodged in stable orbits for tens of thousands of years, silent beacons of an industrial age. Humanity, in less than a century, has expanded its signature from the ocean floor to the edge of space. This record, fragile yet permanent, is the closest thing to proof that civilization exists at all. For if humanity were to vanish tomorrow, the record would remain. Deep in the rocks, future intelligences, whether alien or terrestrial, would see the telltale chemical and radioactive scars, the artificial strata, the sudden bloom and collapse of biodiversity, the strange synthetic molecules no natural process could create. In this way, the Anthropocene is not only a crisis, it is an experiment, a demonstration of what a civilization looks like when viewed through the eyes of geology. We are living inside a case study of our own impermanence, and if it is true here, could it be true elsewhere? Might civilizations across the galaxy flare into existence brief and brilliant, leaving behind only thin layers in the rocks of their worlds? Perhaps the Milky Way is littered not with radio signals or starships, but with geological ghosts, silent, enduring signatures in stone. The tension lies in this possibility that civilizations, no matter how advanced, may leave nothing more than scars, detectable only to those who know to look. The Anthropocene, in its tragedy and its wonder, may be the only message any civilization ever writes across the cosmos. And as Earth continues its slow rotation, one truth grows clearer. We are not only the inheritors of the planet's past, we are also the architects of its memory. The riddle of forgotten civilizations does not end with Earth. It stretches outward into the vast silence between the stars, where the same haunting paradox lingers. If intelligence is not rare, then why do we not see it? This puzzle is known as the Fermi paradox, named after the physicist Enrico Fermi, who once asked the simple question, where is everybody? The galaxy is ancient, billions of years older than humanity, with hundreds of billions of stars, many encircled by planets where conditions for life may have been favorable. If civilizations are common, then surely some should have risen long before ours. Some should have built machines that crossed the interstellar gulfs. Some should still remain, and yet there is only silence. The Silurian Hypothesis, born on Earth, whispers one unsettling possibility. Perhaps civilizations do arise, but their lifespans are fragile, their traces fleeting. They flare for a geological heartbeat, altering their planet, marking its stone and skies, but then they fade. Extinctions sweep them away, tectonics swallows their monuments, and erosion reduces their artifacts to dust. What remains is not cities or machines, but only signatures in chemistry and stone. Civilizations may not endure as empires or legacies, but as faint geological anomalies, mysteries awaiting interpretation. In this light, Earth becomes a microcosm of the cosmos. The Anthropocene is not merely our epoch, but a case study in how intelligent life inscribes itself upon a world. How plastic fragments, carbon spikes, and radioactive shadows may echo across millions of years. But if humanity vanishes, even this will blur into the fabric of time, until only fragments remain, fragments no different from the anomalies found in the rocks of epochs long past. Albert Einstein once reflected that the distinction between past, present, and future is only a stubbornly persistent illusion. Time is not a vault that perfectly preserves, but a tide that reshapes, erases, and buries. Yet within its erasures lie subtle traces, patterns that endure if one knows how to read them. The sediment becomes a palimpsest, a layered manuscript, where every civilization is a line of ink, fragile, faint, but not entirely gone. Stephen Hawking, in his final years, warned of the impermanence of civilizations. He noted that intelligence, far from guaranteeing survival, may hasten its own demise, through weapons, climate upheaval, or ecological collapse. To Hawking, the silence of the cosmos was not reassurance, but a warning. The absence of voices may not mean that intelligence never rises. It may mean that it rarely endures. In this reflection, humanity finds its mirror. Civilizations may be less like eternal monuments and more like cosmic rhythms, brief songs sung against the void, destined to end in silence. The rise and fall of intelligence may be woven into the structure of the universe itself, a cycle repeating endlessly across stars and worlds. Each civilization, convinced of its permanence, learns only too late that time erodes not only mountains and seas, but memory itself. If this is true, then the Fermi paradox dissolves into melancholy clarity. The reason we do not see them is not that they never existed, but that they have already come and gone. Their legacies lie buried in planetary strata, drowned beneath oceans, recycled into mantles, scattered as isotopes too faint to distinguish from natural causes. The galaxy may be filled with the ghosts of civilizations, and Earth may be only one more tombstone in a vast and silent graveyard. And yet this perspective carries not only despair but meaning, for to recognize impermanence is to also recognize significance. The fact that traces vanish makes the present more fragile, more precious. Humanity's story, brief though it may be, becomes part of a universal epic of emergence and disappearance. Each civilization, however fleeting, adds a verse to a cosmic song no one may ever hear in full. The Silurian Hypothesis began as a speculative exercise in geology, but its implications stretch far beyond the rocks of Earth. It is not only about ancient possibilities buried in stone, it is about the fate of intelligence itself. It suggests that civilizations, wherever they arise, are unlikely to be timeless. They are fragile experiments, vulnerable to the very forces they unleash. Perhaps the Anthropocene is not unique, but universal. Perhaps every world with intelligence passes through a similar phase, where industry transforms landscapes, where isotopes mark the soil, where climate shifts to the brink. Perhaps the story always ends with the same silence. The universe, then, would not be empty, it would be haunted. And so the question echoes back to us, heavier than before. Are we the first to awaken intelligence upon this Earth, or simply the latest? And if we are not alone in the cosmos, are we also not the first to vanish into it? The stars remain indifferent. The Earth spins on. And somewhere in the silence between epochs and the silence between stars, the truth waits, written not in words, but in stone. The Earth turns, ancient and indifferent, its surface scarred by oceans, winds, and fire. Beneath, every step lies a depth of time so vast that imagination falters before it. 4.5 billion years, carved into stone, layered into silence. Within this abyss of memory, a question lingers like a shadow. Are we alone in our own past? If others came before, their echoes are faint, erased by the machinery of geology. Their monuments would have fallen, their stories dissolved, their bodies scattered to dust. We would walk unknowingly upon their ashes, inheriting a world already lived in, though stripped of every trace. Every stone beneath us could be a page, already written, a page we no longer have the language to read. But if none came before, then humanity may be something more profound and more fragile, the first spark of intelligence to ignite upon this Earth. If that is true, then ours is a fire born out of silence, a light appearing against 4 billion years of night. It is a thought both humbling and terrifying, for to be the first is to bear the weight of responsibility, to recognize how delicate and rare this phenomenon may be. Civilizations, whether real or imagined, are like waves upon an endless ocean. Each one rises, crests with brilliance, and then collapses into the water, erasing the shape of the last. The sea remembers not the wave, but only the rhythm. So too with time, it does not preserve every spark of intelligence. It carries only fragments, broken signals, hints without clarity. To search for others in the depths of the geological record is to search for foam on waves already gone. This is the paradox at the heart of the Silurian Hypothesis. It does not claim that forgotten civilizations existed, nor that they did not. It simply reveals the silence into which all history eventually fades, and in confronting this silence, humanity must also confront itself. For whether others came before or not, our own impermanence is undeniable. We too are a civilization bound to time, bound to erasure. The question lingers like an open wound. Will we be remembered, or will we too become only a chemical trace in future stone? Will we be a fossilized signature of carbon, a scattering of radioactive isotopes, a thin stratum of plastic pressed into clay? Will any intelligence in the far future, whether on Earth or elsewhere, look back and wonder if we had ever been. The philosopher Søren Kierkegaard once wrote that life can only be understood backwards, but it must be lived forwards. The same could be said of civilizations. They do not see their own endings. They live as though the future stretches endlessly before them, while time prepares to fold their story into silence. Humanity, for all its knowledge, may be no different. The Anthropocene, so vivid to us now, may one day be nothing more than a blur, indistinguishable from countless other geological anomalies. And yet, in this realization lies something beautiful. For even if history does not preserve us as we imagine, even if our monuments crumble and our records dissolve, the present remains luminous. Existence itself becomes the miracle. The chance alignment of atoms, the emergence of thought, the fragile gift of consciousness within a universe mostly silent. Perhaps the meaning is not in how long civilizations endure, but in the fact that they exist at all. If others did rise before us, then our story is part of a lineage unseen, a continuation of intelligence in cycles we cannot remember. If none came before, then we stand at the edge of the abyss as pioneers, the first to dream, the first to wonder, the first to ask the question at all. Either way, the weight is the same: fragility, transience, responsibility. For the greatest mystery may not be whether others came before. The greater mystery is whether we ourselves will be remembered. Will time carry our voices into the deep future, or will they fade as whispers no one hears? The answer may not lie in science alone, but in how we choose to live, to sustain, to endure. And so the Earth continues its quiet turning, indifferent to the sparks that rise and fall upon its surface. Civilizations bloom, civilizations fade, waves upon the ocean, erased, replaced, forgotten. Yet still the ocean moves, still the stars shine. Still the question remains, perhaps it will never be answered, perhaps it is not meant to be. But in asking it, humanity sees itself more clearly. A fragile wave, luminous for a moment, carried across the infinite sea of time. And in that recognition lies the final haunting thought, not whether we were the first, but whether we will be the last.